How's it going? So I'm Alex, and I'm part of the pizza cutting team group for our Dynamics Machines project. As you can see, we 3D printed our pizza cutting mechanism, which just involves a crank slider and then a Geneva wheel for pizza indexing. Um, Also, as you can see here, so we're at a 40% scale on our model. In our actual size, the pizza wheel up here to the left side is 14 inches, and it can sufficiently cut a 14-inch pizza. With the 40% scale model, it made things a lot harder for us in terms of this overall guide rail and the linkage, as you can see here. Also, we decided to make it a PLA and 3D print it rather than machine it. And in our actual prototype, it'd be aluminum or some type of metal that is food safe and just better for in the kitchen. This prototype actually does solve the problem of cutting a pizza as well as indexing it. I'll first demonstrate cutting. So, as you can see here, as the driving part of the Geneva wheel turns, that didn't work. So as the driving part of the Geneva wheel turns, the crank slider mechanism will, what's the best way to do this? There it is. As it turns, the crank slider mechanism will bring the cutter in and out, and it will be able to cut across the entire length of the pizza. And then when it comes to indexing, on the back side of our Geneva wheel design, so we've developed a Geneva wheel that goes alongside the driven portion of this Geneva wheel right here. As you can see, as we rotate, this peg will slide in and out of these grooves, indexing the pizza, as I'm about to show you. The entire model is pretty, it's built kind of like a Lego set where everything is, you can take anything apart, which really helps in the kitchen in terms of cleaning and sanitary issues. So as we cycle our Geneva wheel, as you can see, here's that little locking peg, and it's about to go into the slot. As it's in there, it turns and rotates, and then out the other side. Sorry, it's like super hard to figure out. And our glue did not stick, which is all right. On this, it indexes 6 times, and so it'll be a total of 6 tire cuts. We only have to cycle the driven portion of the Geneva wheel 3 times because of our pizza cutter has the ability to cut across the entire length of the pizza, which is advantageous and kind of what we were looking for in terms of just making an efficient design. Otherwise, so the complete range of motion and linkage system, so this thing will travel further than 14 inches, which is our desired pizza diameter. It travels about 14.5 at the full toggle position at its fully extended point, and then it also will back off of the pizza during its while the pizza is indexing, which is also desired. Let's see if I get to that point. So as you can see, in this position, the pizza wheel is fully extended past the length, past the diameter of the pizza. So you can see right here, which is again a desired effect that we wanted, and that's going to create a toggle position. Due to the mechanical advantage being at the most and almost nearly infinite at this position, it is going to be considered a locking toggle, but you just can power through it, and it cycles very easily, especially with a fully functioning prototype made out of metal where it has bearings and stuff like that. If I was going to continue on this project, I think some of the biggest things I would change are, again, just adding bearings and stuff to the Geneva wheel. Our driving portion of the Geneva wheel with PLA on PLA has a high friction coefficient where it doesn't really like to spin too easily, as well as I would design both the wheels to be able to cut fully through instead of just partially through. And then on the top side, have the portion of the peg protrude out, so that way it's able to rotate and it's much more steady on here. Being at about 40% ratio, or 40% of the actual prototype model, this became extremely hard to manage with our base feature here. As you can see, the base is not like the place where the wheels sit on is not super big, especially at the 40%. It's only about 1/4 of an inch at full scale model, so it's way less than that here. With that being the case, it's made it hard for the pizza wheel to actually sit steady onto the base portion. Yeah, I would definitely change that, as well as I would probably change just the way that the rails slide. We did a second design iteration. So I take this off of our base piece, where our base piece now has a connecting thing up at the top here to keep our guide rails parallel with each other, as well as on the back side here it has another stand to keep it flush and like perfectly straight, which that worked out really well in our design. Making this again out of aluminum rather than PLA or a different type of metal, it'd become a much more efficient design, and I think that we could do a really good job. But this design does solve the problem of making it pretty easy to cut pizza wheel to indexes. And I think that'd be it. So I appreciate your time watching the video. I would thank you for allowing us to work through this project together and being so patient, especially when it comes to our acceleration term in our last part. I think everything worked out really well. I'm very happy with how this turned out, even though it is just a prototype to begin. Sweet, thank you so much.